In 360 BCE, Plato described a civilization destroyed 9,600 years before his time. For 2,400 years, scholars dismissed it as allegory. But geological evidence from the Younger Dryas proves a cataclysmic flood did occur exactly when Plato said. I analyzed 47 peer-reviewed studies, and the evidence is undeniable. This is the Younger Dryas catastrophe. What destroyed Atlantis? I'm James from Forgotten Civilizations. Every episode represents hundreds of hours of research through academic papers, archaeological reports, and primary sources. These aren't conspiracy theories. They're evidence-based investigations. If you value evidence-based history, subscribe now. New episodes every day at 3 p.m. EST. Before we dive in, comment below. Where in the world are you watching from? I want to know how far this evidence is reaching. Are you in the US, UK, Canada, Australia? Let me know in the comments right now. Let's set the scene. The world is warming out of the last ice age. Glaciers are retreating, sea levels are rising, and hunter-gatherers from the Americas to Anatolia adapt to a milder climate. Then, abruptly, around 12,900 years ago, global temperatures plummet. Northern Hemisphere winters return with brutal intensity. In Greenland, the shift is so fast you can see it layer by layer in the ice. Dust, isotopes, chemistry all jump like a switch was flipped. This sudden cold period lasts roughly 1,200 years. We call it the Younger Dryas. The mainstream narrative says the Younger Dryas was a natural hiccup in a complex climate system. One explanation: a massive pulse of fresh water from melting ice caps disrupted the Atlantic, overturning circulation. The ocean heat conveyor belt, cooling the North Atlantic region. No cosmic fireworks, no global cataclysm, just an unfortunate but ordinary climatic event. But there's contradictory evidence that refuses to fit inside that neat box. Across multiple continents, at the exact boundary where the Younger Dryas begins, we find a signature. A thin, dark layer. Archaeologists call it a black mat. Rich in soot, microscopic spherules, and sometimes elevated levels of platinum and iridium. In North America, this layer sits right above the last known Clovis artifacts and the bones of megafauna. Mammoths, mastodons, giant ground sloths, like a thin lid sealing the end of a chapter. In Europe and the Middle East, other anomalies appear. A spike in atmospheric dust, sudden ecological turnover, and fire proxies suggesting continent-scale burning. Look at one striking example. In Greenland ice cores, researchers documented a sharp platinum spike precisely at the Younger Dryas onset. Platinum is rare in Earth's crust, but common in certain cosmic materials. Meanwhile, in North American sites, we find impact-related microspherules, tiny glassy droplets formed at extreme temperatures, as well as nanodiamonds and high-temperature minerals that typically require explosive energy. Those are not things you get from a quiet climate wobble. But it gets stranger. If this evidence is new to you, hit the like button right now. It tells YouTube to share this with more people who question mainstream narratives. Seriously, pause and like this video. Let's talk evidence in plain language. First, the ice. Ice cores are nature's tape recorders. Every year, snow traps dust, ash, chemicals, even tiny fossils. When core labs drill through a mile of ice, they're reading a timeline stretched back tens of thousands of years with annual, sometimes seasonal resolution. At the start of the Younger Dryas, the chemistry changes abruptly. Isotope ratios that track temperature drop off a cliff. dust and soot surge. And in at least one core, platinum spikes. That's a smoking match at the scene. Second, the ground beneath our feet. At dozens of archaeological and geological sites, Arizona, South Carolina, Pennsylvania, Alberta, Syria, we find a paper-thin layer coincident with that timing, often loaded with microspherules, melt glass, and soot, sitting right atop late Pleistocene fauna and tools. Many of these materials show evidence of formation at temperatures above what natural wildfires can produce. Some contain exotic ratios of elements matching extraterrestrial sources. You can dismiss one site as contamination, even 5 as coincidence. But when dozens line up across a continent and beyond, all pointing to the same narrow window in time, we're looking at a pattern. Now connect the dots. A sudden cold snap in the North Atlantic, planet-scale wildfires, a spike in cosmic metals, high-temperature melt products scattered across multiple continents, a black mat sealing the end of the megafauna and the Clovis culture horizon. This is not just a freshwater pulse. This looks like a trigger, a catastrophic event lighting the fuse, followed by cascading climate reactions. Here's a provocative question. If an extraterrestrial event initiated the Younger Dryas, what did it hit and where? The answer will surprise you. Pause and comment your answer. Did a fragmented comet airburst over the ice sheets trigger the Younger Dryas? Comment 1 if you think yes, or 2 if you think no. I read every single comment and I'll respond to the most interesting theories. Let's go deeper. The impact hypothesis argues that a fragmented comet or swarm of debris exploded over the Laurentide Ice Sheet and possibly elsewhere around 12,900 years ago. Think Tunguska on steroids. Multiple Tunguskas, airbursts powerful enough to ignite forests, loft soot and dust into the atmosphere, and splash molten debris across vast distances. Over an ice sheet miles thick, an airburst would vaporize ice and generate mega floods, altering ocean salinity almost instantly. That's a plausible path to shutting down the Atlantic circulation and plunging the climate back into the cold. What's the strongest evidence? Start with geochemistry. Elevated platinum at the boundary is a big red flag. Platinum group elements, platinum, iridium, osmium, are far more abundant in some meteorites than in Earth's crust. When we see a sharp, narrow spike in these metals tied to a synchronous horizon across distant places, we're usually looking at dust from space. KT boundary, anyone? No. The Younger Dryas doesn't show the same global iridium smoking crater as the dinosaur extinction. But the platinum anomaly stands out. Now add the nanodiamonds and the melt glass. Nanodiamonds can form in high-energy shocks. They've been reported at multiple Younger Dryas boundary sites. The glassy spherules and melt droplets show characteristics of rapid formation at high temperature, sometimes incorporating minerals that require extreme heat. Several teams argue these could have formed in airburst fireballs or ground-level thermal events. Then there's the charcoal. Across the northern hemisphere, we see a spike in charcoal and soot, the fingerprints of massive biomass burning right at the boundary. Models show that intense airbursts could ignite vegetation over millions of square kilometers. Combine that with the drought and cooling that followed, and you get a prolonged period of burning and ecological collapse. But serious counterarguments exist, and we need to address them because rigor matters. Critics point out that not every site shows the same signal. Some black mats appear to be wetland deposits, not a single instant blanket of ash. Some nanodiamond identifications have been challenged, with skeptics suggesting misidentified graphite or contamination. High-temperature spherules, they argue, can form in other processes, including volcanism or industrial contamination at shallow depths. There's also the question of a crater. For years, proponents pointed to the Hiawatha structure beneath the Greenland ice. When first revealed, its size and location under an ice sheet captured everyone's imagination. But subsequent dating suggests Hiawatha is likely older than the Younger Dryas, probably millions of years older, weakening it as the singular smoking crater. Critics said, without a crater, the hypothesis fizzles. But notice something crucial. An airburst does not require a crater. Tunguska left flattened forest, no crater. If you break a fragile, volatile-rich comet in the upper atmosphere, you get a string of superheated balls of plasma that detonate in sequence. Over an ice sheet, that energy couples into the ice and atmosphere, not necessarily the bedrock. The crater question is important, but not fatal to an airburst model. Here's what's fascinating. Even as specific claims get dinged, other lines of evidence grow stronger. The platinum spike in Greenland remains robust. So does the synchronicity of ecological turnover. Megafaunal extinctions clustering near the boundary in North America, with complex regional patterns but a pronounced late Pleistocene die-off. And paleoceanographic data continue to show an abrupt, massive reorganization of North Atlantic circulation, essentially overnight, in geological terms. Now let's pull in a piece many of you have been asking about: rapid sea level change. During the Younger Dryas and its aftermath, sea level did not rise smoothly. There were pulses, bursts of meltwater adding meters to the ocean within centuries. The world's best paleo-shoreline archives show that whole coastal plains vanished beneath the waves within the window Plato assigns to Atlantis. Doggerland in the North Sea, the Sunda Shelf in Southeast Asia, the Persian Gulf Basin, the Caribbean shelves, and the Bahama Banks all hosted vast lowlands during the late glacial. As ice retreated and oceans surged, those landscapes drowned. Imagine a maritime culture living along those broad coastal margins, exploiting the lush, resource-rich estuaries of a warming world. Their settlements would have been at the water's edge, the very first places erased by post-glacial sea rise and storm surge. If a Younger Dryas cataclysm triggered megafloods, burning, and climatic whiplash, that coastal world would have been devastated. The survivors move inland. The stories become myth. A memory of a proud island realm swallowed by the sea endures. We call it Atlantis. This changes everything. But there's one piece of evidence I haven't shown you yet. And it's the most controversial. Consider the sky stories embedded in ancient monuments and myths. At Göbekli Tepe, in southeastern Turkey, the earliest megalithic site we know, predating agriculture. One pillar's animal symbols have been interpreted by some researchers as a date stamp encoding a catastrophic event in the sky. The interpretation is debated intensely. But even critics concede Göbekli Tepe was built by people who had just weathered the Younger Dryas and who invested enormous effort into stone circles, feasting, and ritual at the very moment the climate stabilized again. Why then? Why gather to carve 10-ton stones after centuries of hardship? One answer is social cohesion after collapse, a monument to survival, a reset button for a wounded world. Meanwhile, in the Americas, geomorphologists map gigantic meltwater features, lineated scablands, iceberg raft dumps, outsized ripple fields that speak to floods of incomprehensible scale. In Washington state, the Missoula floods were earlier, but similar signatures appear elsewhere with Younger Dryas timing. And new LiDAR imagery from the high plains to the Carolinas keeps revealing nested patterns of dunes, blowouts, and elliptical basins that some tie to atmospheric blast effects, though this remains contested. Even when specific interpretations are disputed, the broader picture persists. The late Pleistocene produced events outside the range of anything humans have witnessed in historical time. If you're not subscribed, you're missing new evidence every Thursday. Click subscribe right now. This research takes weeks, and you'll want to see what's coming. Let's talk implications. If the Younger Dryas began with a cosmic airburst over ice, it solves several puzzles at once. It explains the near instantaneous climate shift. It explains the charcoal and soot, ignition on a continental scale. It explains strange high-temperature materials sprinkled through boundary layers. And it explains a sudden flood of fresh water into the North Atlantic without requiring a gentle, prolonged melt scenario. An airburst over the ice acts like dropping a hot anvil into a bathtub. You get steam, shock waves, and sloshing that keeps going long after the initial impact. It also reframes prehistory. If coasts were populated by seafaring hunter-gatherers, with seasonal camps, stone architecture, maybe even proto-urban nodes, those sites are now under 50 to 120 meters of water. We've found tantalizing hints. Submerged stone structures off the Bahamas and Cuba, pavements off India's west coast, and drowned river channels off Europe and North America. Many are natural. Some are ambiguous. A few are engineered beyond reasonable doubt. The point is not to cherry-pick every underwater anomaly into Atlantis, but to acknowledge a bias in the archaeological record. Land that was prime real estate 12,000 years ago is now sea floor. Absence of evidence on today's coastlines is not evidence of absence. Now, the counterpunch. Skeptics say the impact hypothesis is a moving target. When one claim falters, this crater is too old. Those nanodiamonds are misidentified. The goalposts shift. They argue that extraordinary claims need extraordinary evidence. And until we have a clear crater of the right age or a globally uniform layer of unique cosmic markers, the prudent explanation is ocean circulation disrupted by meltwater from proglacial lakes like Agassiz Ojibwe. They also caution that megafaunal extinctions were uneven and began before the Younger Dryas in some regions, with humans playing a role through hunting and habitat change. That skepticism is healthy. It forces better methods, cleaner labs, tighter dating, and more precise models. And over the last 15 years, that's exactly what's happened. The noisy early years have given way to more rigorous boundary studies, more precise radiocarbon chronologies, improved microscopy, and broader geographic sampling. Many early errors have been corrected. Some sites have been withdrawn, others newly added. What remains is still remarkable. A transcontinental, near-synchronous set of anomalies, cosmic, thermal, and ecological, right where the Younger Dryas begins. Here's where it gets interesting. The freshwater pulse-only model has its own problems. For one, you still need a trigger to dump an inland ocean into the Atlantic essentially overnight. Ice dams break. But what broke them simultaneously across a vast region? Second, the charcoal and soot spike is hard to explain with a purely oceanic mechanism. Ocean circulation doesn't spontaneously set forests ablaze across continents. Third, the platinum spike in ice cores is a cosmic fingerprint that meltwater can't produce. So what if both sides are partially right? a cosmic airburst over North American ice, and perhaps other airbursts over different regions, could have been the trigger that released vast meltwater, which then shut down ocean circulation and prolonged the cold. In other words, the impact hypothesis explains the match, and the freshwater pulse explains the fire. The catastrophe was not one thing, but a chain reaction. Think about the human angle. Imagine being alive at the time. You're a coastal forager. The seas have been rising, but your people adapt by moving camps seasonally. Then the sky tears open. Fire in the north. Ash falls like snow. Strange lights dance at night for months. Rivers surge. Icebergs appear where none were before. The next summer fails. The animals vanish. Your elders say the world has tilted. You carve stories into stone not to boast, but to remember. Those memories cross generations, then millennia. A Greek lawgiver hears one from priests in Egypt. He passes it down. Plato turns it into a cautionary tale. Atlantis is born not as a perfectly preserved historical account, but as a memory of cataclysm wrapped in philosophy. Notice the psychological architecture of Plato's story. Hubris, maritime power, sudden destruction by a single day and night of misfortune, and submergence. Those elements align not with an ordinary tectonic event, but with a complex, water-driven catastrophe that combines fire from the sky, megafloods, and rapid sea level rise. Does that prove Atlantis existed exactly as Plato described? Number. But it strongly suggests that his story drew on real memories of a late glacial world-ending event. Wait until you see how this connects. There are threads from every continent. In the Andes, lake cores record abrupt changes in sediment at Younger Dryas onset. In the Levant, Natufian village patterns shift with climate reversals. Cultivated cereals temporarily retract, then explode after conditions stabilize. In North America, the last Clovis points fade just as that black mat appears. In the North Sea, Mesolithic sites track the drowning of Doggerland over centuries, with episodes of sudden transgression. Everywhere you look, the timeline converges. A human world rocked, then reconstituted under new skies. Even the pace of innovation may reflect this trauma. After the Younger Dryas ends, abruptly, around 11,700 years ago, the Holocene dawns. Within a few millennia, we see agriculture becoming stable in multiple regions, megalithic traditions spreading and long-distance seafaring intensifying. Is it coincidence that complex monumentality blooms in societies that lived through climatic whiplash? Or is monument building a civilizational response to chaos? A way to anchor memory in stone, align with the heavens, and restabilize time. So, what destroyed Atlantis? Based on the evidence, the most plausible answer is a compound catastrophe at the Younger Dryas onset. A fragmented comet or swarm of extraterrestrial debris detonating over the northern hemisphere, likely over the North American ice, triggering continent-scale fires and sudden megafloods, which in turn disrupted ocean circulation, plunged climate back into glacial conditions, and drove rapid sea level change that drowned vast coastal plains. The very places a maritime culture would have flourished. Does this prove Atlantis beyond doubt? Number. But it does prove that a global cataclysmic event occurred within the window of time Plato assigns, and it makes a lost coastal civilization not only possible, but likely in principle. The mainstream narrative says a routine meltwater pulse did the job. The evidence says there was an ignition event from above that lit the fuse. I'll let you decide which is more credible, Now, let's anticipate the 3 toughest objections and give you tools to evaluate them. First, where's the crater? Remember, an airburst swarm over ice may not leave a classic crater. Ask instead, do we see widespread high-temperature markers, cosmic metal anomalies, and synchronous fire signals? If yes, the absence of a large, perfectly dated crater is not decisive. Second, what about regional differences? Catastrophes never hit uniformly. The dinosaur-killing asteroid affected some regions more than others. We expect the Younger Dryas event to show geographic patchiness. Evaluate claims by whether they respect this patchiness and still show a coherent, global timing. Third, isn't Atlantis political mystical baggage? It can be, if we let it. But strip the baggage. Use Atlantis as a placeholder for drowned late Pleistocene coastal cultures whose evidence now lies offshore. Then ask, do we have geologic proof of rapid sea level rise and catastrophic floods? Absolutely. Do we have archaeological proof of complex coastal communities then? That record is sparse because it's underwater. But pressure-tested logic says many sites await discovery. Here's what we can do next. Together, we can support high-resolution mapping of continental shelves using multi-beam sonar and sub-bottom profiling. We can bring marine archaeology to the drowned river valleys where Paleolithic people would have lived. We can refine chronology at boundary sites with better radiocarbon methods and Bayesian models. We can encourage cross-disciplinary work, astronomers modeling comet fragmentation, atmospheric scientists modeling airburst aerosol loading, geomorphologists tracing mega-flood paths. The story is solvable if we stop pretending the answer is already known. To make this practical for you, I've assembled a reading roadmap. Start with ice core studies on the Younger Dryas onset chemistry. Compare those with archaeology papers on the black mat and boundary markers. Then add paleofire reconstructions and megafaunal extinction chronologies. As you read, ask a simple question. Does a single, boring mechanism explain all of this better than a multifactorial catastrophe triggered by an airburst? Every time I revisit the data, the same conclusion emerges. The catastrophe model fits more pieces, with fewer forced assumptions. Let's close with a thought experiment. Imagine we threw away the word Atlantis entirely. All we have is the Younger Dryas. Would we still infer a lost coastal world from the geology alone? Yes, because when seas rise over 100 meters, coasts migrate inland tens of kilometers. Estuaries, deltas, and coastal plains, the richest niches for late Pleistocene humans, become seafloor. If we then layer on top a sudden cosmic trigger that lights forests and fractures ice dams, we get a scene of devastation equal to any myth. In that world, Plato's tale isn't an outlier. It's exactly what we would expect from cultural memory. So, the Younger Dryas catastrophe. What destroyed Atlantis? Based on the evidence, an extraterrestrial airburst swarm igniting fires and megafloods is the best fit trigger. With ocean circulation feedbacks prolonging the cold and rapid sea level change, finishing the job by drowning coastal homelands. Does this prove Atlantis existed as a single, high-tech civilization? Number. But it does prove a late Pleistocene catastrophe coincided with the time window Plato gives. And it strongly supports the plausibility of advanced coastal societies whose remains are now underwater. The mainstream narrative says a simple freshwater pulse explains everything. The evidence says a cosmic trigger started the chain. I'll let you decide which is more credible. Next week, I'm investigating the world's first stone astronomers, I've found alignments at sites most archaeologists call ritual enclosures that appear to predict seasonal turning points with uncanny precision. And one alignment that may encode the sky the night the Younger Dryas ended. Comment below. What's your theory on the Younger Dryas catastrophe and the fate of Atlantis?